This is the Edexcel Level 2 certificate in Extended Maths, and this is paper 2 of the sample papers, which is a calculator paper. Question number 1, Part A. Factorise x squared subtract 25. Here we have a difference of two squares. Therefore, x squared subtract 25 is equivalent to x plus 5 multiplied by x subtract 5. Part B. Write x subtract 3 multiplied by x plus 7 multiplied by x plus 3 multiplied by x subtract 6 in the form x squared subtract d multiplied by ax squared plus bx plus c, where a, b, c and d are integers. So we have this expression which we need to write in this required form. Because of commutativity, I can rewrite this as x subtract 3 multiplied by x plus 3 multiplied by x plus 7 multiplied by x subtract 6. Now, x subtract 3 multiplied by x plus 3, that's a difference of two squares. In other words, we have x squared subtract 9. And then x plus 7 multiplied by x subtract 6, we can work out. X multiplied by x is x squared. Then we have x multiplied by negative 6 plus 7 multiplied by x, that's just 1x. 7 multiplied by negative 6, that's negative 42. And therefore, the expression x subtract 3 multiplied by x plus 7 multiplied by x plus 3 multiplied by x subtract 6 is equivalent to x squared subtract 9 multiplied by x squared plus x subtract 42. Question number 2. W, x, y and z are four consecutive integers. We have to prove algebraically that for any set of four consecutive integers, yz subtract wx is equal to the sum of the four consecutive integers. Now, for this question, let w equal n, then x will equal n plus 1, y will equal n plus 2, and z will equal n plus 3. You will find here we have four consecutive integers. So, for the sum, w plus x plus y plus z, that's equal to n plus 1 plus n plus 2 plus n plus 3. And if we work all of this out, n plus n plus n plus n, that's 4n. 1 plus 2 plus 3, that's 6. We end up with 4n plus 6. And if we have yz subtract wx, well, that's equal to n plus 2 multiplied by n plus 3 subtract n multiplied by n plus 1. So, n times by n is n squared. N multiplied by 3 plus 2 multiplied by n, that's 5n. 2 multiplied by 3, that's 6. And then we subtract n times by n, which is n squared. And then we subtract n times by 1, which is negative n. And if we simplify this, you will note that n squared subtract n squared is 0, n squared. 5n subtract n is 4n. And then we add on 6 to this, leaving us with 4n plus 6. In which case we then see our statement is true. Question number 3. Triangles ABC and PQR are similar. Triangle ABC is an isosceles triangle where one of the angles is 40 degrees, one of the angles is obtuse, two of the sides are each 10 centimeters. The length PQ is equal to 1.5 multiplied by the length AB. You have to work out the area of the triangle PQR. Give your answer correct to three significant figures. Here is the triangle ABC. we've got one of the angles which is 40 degrees and one of the angles is obtuse. So the base angles will therefore be the same as 40 degrees each, and the obtuse angle will be 100 degrees. Notice 40 plus 40 plus 100 gives the 180 degrees, which is the sum of the angles in a triangle. And we've got two of the sides which have a length of 10 centimeters. Hence, ABC is this triangle shown here. We also have the triangle PQR, which is similar to triangle ABC. And if they are similar, that means the angles are the same as we see in the triangle ABC. And we know that the length of PQ is the length of AB multiplied by 1.5. 10 multiplied by 1.5 is 15, which means that PQ and QR are 15 centimeters. We now have enough information to work out the area of the triangle PQR. The area of the triangle PQR, that's equal to a half multiplied by 15 multiplied by 15 multiplied by the sine of 100. So let's work this out. We have 1/2 multiplied by 15 multiplied by 15 multiplied by the sine of 100, and it turns out we get 110.79, etc. To three significant figures, we have 111 centimeters squared. Question number 4. The graph of y equals ab to the negative x passes through the point 0, 0.7 and 3, 0.0875. For the first part of part 4, we have to find the value of a and the value of b. What we can do is substitute in these points into this equation. Let's consider the point 0, 0.7. Substituting into y equals ab to the negative x, we have 0.7 equals a multiplied by b to the power of 0. So we have 0.7 equals a multiplied by b to the 0, which is 1. We can therefore conclude a is equal to 0.7. Let's substitute in the point 3, 0.0875 into y equals ab to the negative x. We have 0.0875 equals a multiplied by b to the negative 3. So we have 0.0875 equals a, which is 0.7, multiplied by b to the negative 3. What we can now do is divide both sides by 0.7, and if we do that, we end up with 0.125 equals b to the negative 3. So in other words, if we were to solve for b, you will find that b is equal to 2. So we have a equals 0.7, b equals 2. Hence, on the grid below, sketch the graph of y equals ab to the negative x. Here we have a negative reciprocal graph as shown here. We have the graph of y equals ab to the negative x. Question 5, Part A. Sketch the graph of y equals sine x degrees for x being in between negative 180 and 180 degrees. If we sketch this graph, you can see the graph of y equals sine x. We have a minimum at negative 1 and maximum at 1. Part B. Solve 2w squared plus 3w plus 1 equals 0. We can factorize as 2w plus 1 multiplied by w plus 1 equals 0. If we have 2w plus 1 equaling 0, that means w equals negative 1/2. And if we have w plus 1 equaling 0, that means w equals negative 1. So the solutions to the equation 2w squared plus 3w plus 1 equals 0 are w equals negative 1/2 or w equals negative 1. ABC is a right-angled triangle. Part C. Use Pythagoras' theorem to show that sine squared theta degrees plus cos squared theta degrees equals 1. The first thing we can do is label the sides of the triangle. We have the opposite, we've got the hypotenuse, and we've got the adjacent. Now, if we use Pythagoras, the hypotenuse squared equals the opposite squared plus the adjacent squared. And if we use trigonometric ratios, we know that sine theta equals the opposite of the hypotenuse, in which case you can say the opposite is equal to the hypotenuse multiplied by sine theta. Cos theta is equal to the adjacent of the hypotenuse, in which case we can say the adjacent is equal to the hypotenuse multiplied by cos theta. What we can now do is use Pythagoras' theorem as well as these trigonometric ratios to show the required result. So, we've got the hypotenuse squared, which is equal to the opposite squared, so that's hypotenuse multiplied by sine theta squared, plus the adjacent squared, so we add on the hypotenuse multiplied by cos theta squared. Let's rewrite this as hypotenuse squared equals hypotenuse squared sine squared theta plus hypotenuse squared cos squared theta. And if I divide both the left hand side and the right hand side by hypotenuse squared, well, what we will end up with is the following. Hypotenuse squared divided by hypotenuse squared is 1. Hypotenuse squared sine squared theta divided by hypotenuse squared is just sine squared theta. Hypotenuse squared cos squared theta divided by hypotenuse squared is cos squared theta. So we have 1 equals sine squared theta plus cos squared theta, which is the result we wanted to show. Given that sine squared x plus cos squared x equals 1 is true for all values of x, part D, solve 3 subtract 2 cos squared x degrees plus 3 sine x degrees equals 0 for x being in between negative 180 degrees and 180 degrees. Now, clearly, we will have to use the identity sine squared x plus cos squared x equals 1. And what we can do is rearrange for cos squared x in this identity and replace the cos squared x with 1 minus sine squared x. The reason for that is we will be left with a quadratic in sine only. So, 3 subtract 2 cos squared x plus 3 sine x equals 0 will then become 3 subtract 2 multiplied by 1 subtract sine squared x plus 3 sine x, and this is equal to 0. So, negative 2 multiplied by negative sine squared x, that's 2 sine squared x. We add on to this 3 sine x, 3 subtract 2 multiplied by 1, that's 1. And this is equal to 0. So we've got 2 sine squared x plus 3 sine x plus 1 equals 0. Now, that equation is similar to what we have in part B. We have 2w squared plus 3w plus 1 equals 0. The difference between this equation and our quadratic in part D is that here we have a w, in part D we had a sine x. So, essentially, w is equal to sine x. And if that's the case, we can use the solutions of w equals negative 1/2 and w equals negative 1 to help us find out what sine x is. So, if we use part B then, sine x is equal to negative 1/2 and sine x is equal to negative 1. And what we'll do is we'll use the graph to help us find the solutions of x. So we've got the sine x equaling negative 1/2 and the sine x equaling negative 1. And let's demonstrate these on the graph in part A. So we've got this negative 1/2 and we've got this negative 1, and we've got the intersection of negative 1/2 with sine x being here and here, and we've got the intersection of negative 1 and sine x being here. So if we read off the values from our graph, we've got an intersection here at negative 150, we've got another intersection here, negative 90, we've got another intersection here at negative 30, which means x is equal to negative 150, negative 90 and negative 30. These are our solutions in the required domain. Question number 6, part A. Use the factor theorem to show that x subtract 2 is a factor of x cubed subtract x squared subtract 14x plus 24. Our first step is to let f of x equal x cubed subtract x squared subtract 14x plus 24. Now we want to show that x subtract 2 is a factor of f of x. What we will do is we will set the x subtract 2 equal to 0. And if we set x subtract 2 equal to 0, we can see then x is equal to 2. What we will now do is substitute in 2 for x. We will, in other words, find out f of 2. So f of 2 is equal to 2 cubed subtract 2 squared subtract 14 multiplied by 2 plus 24, and it turns out here we get 0. And therefore, because f of 2 is equal to 0, we can therefore conclude x subtract 2 is a factor of f of x. Hence or otherwise, given that x equals 2y, part B, write the expression 8y cubed subtract 4y squared subtract 28y plus 24 as a product of its linear factors. Before we do anything else, let's see how far we can factorize x cubed subtract x squared subtract 14x plus 24. So we've got x subtract 2 multiplied by some quadratic factor ax squared plus bx plus c. This will be equivalent to the cubic x cubed subtract x squared subtract 14x plus 24. We are required to find out what this quadratic factor is. So we've got the x subtract 2, and I obviously will have an x squared term because x multiplied by x squared will give the x cubed. Now I've got the negative 2 times by the x squared, which is negative 2x squared. Here I've got a negative 1x squared. To go from negative 2x squared to negative 1x squared, I need to add on x squared, which means I add on an x term here, and this is just by inspection. Then I've got negative 2 multiplied by some constant gives 24, so negative 2 multiplied by negative 12 gives the 24. So I can further simplify the left hand side. I've got x subtract 2, and the x squared plus x subtract 12 I can write as x plus 4 multiplied by x subtract 3, and this is equivalent to the given cubic. Now, what we know so far is we have the expression 8y cubed subtract 4y squared subtract 28y plus 24. And we know that x equals 2y. So we can rewrite this expression as 2y cubed, which is the same as 8y cubed, subtract 2y squared, which is the same as negative 4y squared, subtract 14 multiplied by 2y, which is the same as negative 28y, plus the 24. But because x is equal to 2y, that's what we were told in the question, we can replace the 2y with x, leaving us with 8y cubed subtract 4y squared subtract 28y plus 24 being equivalent to, well, here what we can do is use this result of x subtract 2 multiplied by x plus 4 multiplied by x subtract 3. We'll replace the x with 2y. So we have 2y subtract 2 multiplied by 2y plus 4 multiplied by 2y subtract 3. We have expressed 8y cubed subtract 4y squared subtract 28y plus 24 as the product of its linear factors. Question number 7. Use the trapezium rule to find an estimate for the area of the region under the curve y equals 2 to the x and between x equals 1, x equals 7 and the x-axis. Use 4 strips of equal width. Give your answer correct to 3 significant figures. So, we are going from x equals 1 to x equals 7 using 4 strips of equal width. So we need to find out how much our increment is worth. So to work that out, we can do 7 subtract 1, then divide by 4, which is the number of strips, we get 1.5, meaning we go up in increments of 1.5. So if we create a table of values of x and y, we start off with x equals 1, we add on to this 1.5 to get 2.5, we then add on to this 2.5, 1.5 to get 4, we add on to this 4, 1.5 to get 5.5, we add on to this 5.5, 1.5 to get us 7. So we have found our x values, and the corresponding y values can be found by substituting back into y equals 2 to the x. X equals 1, y is 2 to the 1, x is 2.5, y is 2 to the 2.5, x is 4, y is 2 to the 4, x is 5.5, y is 2 to the 5.5, x equals 7, y is 2 to the 7. What we can now do is label these y values, and we can label them as y0, y1, y2, y3 and y4. Therefore, the area is approximately equal to, using the trapezium rule formula, 1/2 multiplied by 1.5 multiplied by, well, we've got our first y value 2 to the 1 plus twice the middle y values 2 to the 2.5 plus 2 to the 4 plus 2 to the 5.5 plus the final y value 2 to the 7. So let's work this out. We have 1/2 multiplied by 1.5 multiplied by 2 to the 1 plus 2 multiplied by 2 to the 2.5 plus 2 to the 4 plus 2 to the 5.5 plus 2 to the 7. That leaves us with 197.86, etc., which to 3 significant figures we end up with 198. So the area is equal to 198 units squared to 3 significant figures. Question number 8. ABCD is a triangular based pyramid, and that's what we see here. E is a point on the line AB, that's here. F is a point on the line CE such that the ratio CF to FE is 3:2, and the point F is shown here. BC is 7.2 centimeters, BF is 4.1 centimeters, the angle CBF is 49 degrees, the angle CED is 109 degrees, and the angle CDE is 32 degrees. We have to find the length of CD, give your answer correct to 3 significant figures. What we will do is we will consider the triangle ECB to begin with, given the information we have. Here is the triangle ECB. We've got this point F which lies on CE. We've got CB being 7.2 centimeters. We have FB being 4.1 centimeters. The angle CBF being 49 degrees. And what we can do with this information is use the cosine rule to work out what CF is, because we have a side, another side, and an included angle, and we are working the side opposite to this included angle. So if we use the cosine rule, we have CF squared equals 7.2 squared plus 4.1 squared, subtract 2 multiplied by 7.2 multiplied by 4.1 multiplied by the cosine of 49 degrees. So let's work this out. So we have 7.2 squared plus 4.1 squared, subtract 2 multiplied by 7.2 multiplied by 4.1 multiplied by the cosine of 49. And it turns out CF squared is equal to 29.9, etc. So what we need to do is find out what CF is, and we can do that by working out the square root of this value here. And it turns out CF is equal to 5.46, etc. Now what we can do is find out what CE is. So CE, that's equal to, well, if we have CF to FE equaling 3:2, I can multiply CF by 5 over 3 to work out what CE is. So I've got 5 over 3 multiplied by this 5.46, etc. So if I multiply this by 5 over 3, CE is equal to 9.11, etc. Now I need to work out the length CD, so let's consider the triangle DCE. So we've got the triangle DCE. We've got CE, which we've just worked out to be 9.11, etc. We've got this 109 degrees, which is the angle CED, and we've got the angle CDE, which is 32 degrees. And we are finding this length, x. So for us to find out what x is, we can use the sine rule, because we've got a side, an angle opposite, a side and an angle opposite. So using the sine rule, we have x over the sine of 109 degrees equaling 9.11, etc. over the sine of 32 degrees. And if I rearrange for x is equal to 9.11, etc. multiplied by the sine of 109 degrees divided by the sine of 32 degrees. So let's work this out. We've got this value of 9.11, etc. We multiply by sine of 109, and then we divide by sine of 32. So it turns out x is equal to 16.26, etc. to 3 significant figures, we've got 16.3. Question number 9. Savio is buying base cupboards for a catering kitchen. The cupboards come in two sizes, 600mm wide and 900mm wide. Let X be the number of 600mm cupboards and Y be the number of 900mm cupboards. The constraints are X is greater than 2 and Y is greater than 0 but less than or equal to 9. Part A, explain in context what Y being greater than 0 or less than or equal to 9 represents. Well, what this would represent is the number of 900mm cupboards must be greater than 0 and 9 or less. A 600mm cupboard costs £210, a 900mm cupboard costs £240. Savio has a maximum budget of £3,600. The total width of all the cupboards is 12 meters or less. Part B, use this information to show that 7x plus 8y is less than or equal to 120 and 2x plus 3y is less than or equal to 40. Well, if we've got x representing 600mm cupboards and y representing 900mm cupboards, and we know that the cost for 600mm cupboards is 210 and the cost of 900mm cupboards is 240, we have 210x plus 240y, and this is less than or equal to, because it's got a maximum budget, 3,600. And if I divide through by 30, we can conclude 7x plus 8y is less than or equal to 120. What we also know is the total width of all the cupboards is 12 meters or less. So we've got 600x plus 900y being less than or equal to 12,000. 12,000 is the same as 12 meters. So we are making the units consistent here. And if I divide through by 300, you will find 2x plus 3y to be less than or equal to 40. Part C. Draw a line on the grid and identify the feasible region. Label the feasible region R. We know one of the constraints is x is greater than 2, so we need to draw the line x equals 2. Here is the line x equals 2. We've got another constraint that y is in between 0 and 9, so we need to draw the line y equals 9, and that is shown here. And we've also got these lines which we need to plot. Now first of all, for us to draw the line 2x plus 3y equals 40, we need 2 points. So let's think about a particular x value, such as x equals 20. When x equals 20, the corresponding y value is 0. Let's think of another point. So for example, when x is 2, you will find y to equal 12. So we can draw the line 2x plus 3y equals 40 with these points. And plotting as necessary, we have 2x plus 3y equals 40. And similarly, to draw the line 7x plus 8y equals 120, we need 2 points. So for example, when x is 4, y is 11.5, and when x is 8, y is also 8. So we need to plot this as well. And doing so, we end up with this line here. So then for our feasible region, that's shown here. Savio decides to buy 7 of the 600mm cupboards and the maximum number of 900mm cupboards possible. Part D, work out the total amount of money Savio will spend buying these cupboards. Well, if we plot where x is 7 and we want the maximum y, that is over here, corresponding to a maximum y value of 8. Meaning, we have 8 of the 900mm cupboards we require. So for the cost, we've got 7 times by 210, that's the cost of 600mm cupboards, plus 8 multiplied by 240, that's the cost of 900mm cupboards, and if you work out the total, that's 3,390. Question number 10. A bag contains only red counters and yellow counters. There are more yellow counters than red counters. The counter is taken at random from the bag, the colour noted, and then the counter is put back into the bag. This process is repeated one more time. The probability that exactly one of the two counters taken from the bag was red is 0.255. Simon then takes one counter from the bag. Find the probability that Simon takes a yellow counter from the bag. What we are required to do is find the probability of yellow, and we know that there are more yellow than red. So what we will do to begin with is let the probability of yellow equal x. And if that's the case, then the probability of red will equal 1 subtract x. Remember, probability adds up to 1. Now, we know that the probability that exactly one of the two counters taken from the bag was red is 0.255. So we have the probability of red multiplied by the probability of yellow plus the probability of yellow multiplied by the probability of red. This is equal to 0.255. This is exactly 1 red. So, we know what the probability of red is, that's 1 subtract x. We know what the probability of yellow is, that's x. And then we add on the probability of yellow, that's x, multiplied by the probability of red, that's 1 subtract x. And this is equal to 0.255. So, because of commutativity, we have two lots of x, lots of 1 subtract x equals 0.255. And if I divide through by 2, x multiplied by 1 subtract x is equal to 0.1275. So therefore, we have x squared subtract x plus 0.1275 equals 0. And we are required to find out what x is. And we can do this using the quadratic formula. Now we know a is 1, b is -1, and c is 0.1275. So when we substitute into the quadratic formula, we have x equals negative b, so that's negative 1, plus, and the reason we want the plus is because we want the value of x, and we know that there are more yellow than red, which is why we take the positive. Then we have the square root of -1 squared, subtract 4, multiplied by 1, multiplied by 0.1275, divided by 2 multiplied by 1. So let's work out this. We have negative 1 plus the square root of -1 squared, subtract 4, multiplied by 1, multiplied by 0.1275, divided by 2 multiplied by 1. If I work out what this is equal to, we get 17 over 20, which is 0.85. So the probability of yellow is 0.85.